Or if you just want to tell me x equals 9, x equals -1, I would accept that as well. Over here is another full example. This one, the solutions are irrational. That does not mean they're imaginary. It just means that they are not nice whole numbers. So again, we see factoring of the perfect square. 4x squared is a perfect square. 25 is a perfect square. So I'm already thinking 2x and 5 to get the 4x squared and the 25. I need to check the middle piece. In the middle there, let me use a different color so we can distinguish between everything here. In the middle, I should have 2 times 2x times -5. So twice my first piece and my second piece. So that altogether should give me -20x, which is what I have. So that checks out. If you want to FOIL it completely to check, go for it. You'll get the same answer. So all of that is equaling 32. So I'm going to do 2x minus 5 squared equals 32. I square root both sides. Square root of 32 is, again, not a nice number. That's why we end up with a radical in our solution. So I have 2x minus 5 equals the square root of 32. 2x minus 5 equals negative square root of 32, the positive and negative version of the answer. They have simplified this down, the square root of 32. Let me show you how that happened real quick. So I'm going to switch over to another piece of paper. So the square root of 32, I can factor that into the square root of 2 times 2 times 2 times 2 times 2. When you factor the 32 down as far as you can into its prime numbers that make it up. Because this is the square root, and the little number in here is a 2, we never write it, but it's there. If we had a cube root, we would have written it like all the time. But square roots we never have to write. That means I am looking for pairs of numbers inside. Pairs of the same number inside. So I see a pair of 2s, a pair of 2s, and then the single 2 is left over. Because I have a pair of 2s there, that's really the square root of 4, which I know is 2. And the square root of 4, which I know is 2. And then the square root of 2, which I don't know the nice answer to because it is a weird decimal. It's irrational, so it just gets left there. So outside I have a 4, and inside I am left with the square root of 2. So that's how the square root of 32 becomes 4 square root of 2. When we go back over to this these notes here. So if you need to see that part again, feel free to pause, rewind the video to look at that again. Here we go. So I have 2x minus 5 equaling 4 square root of 2. 2 steps here to get to my final answer. I need to add the 5 to the other side. In fact, I'm going to go back to my other page because they skipped a couple steps here, so I just want to show you how they work. So let's do this so we can see it all. Okay. So they took 2x minus 5, which equals 4 square root of 2. We're going to add 5 to the other side. Now an irrational 4 square root of 2 plus 5. They don't really mix. It's like oil and water. So I'm just going to write them as 4 square root of 2 plus 5, just next to each other. And then I'm going to divide by 2. So I have x equals 4 square root of 2 plus 5 divided by 2. On the other side, it's very similar, except it's the negative 4 square root of 2. I add the 5. I divide by 2. And, excuse me, that is how we get our 2 answers. They wrote it, notice, as one answer. If you gave it to me as separate or as one, either way it's fine. Notice all they did is showed me a plus minus as opposed to this one's positive, this one's negative. They just combined them as one answer. That's all they did. Alrighty, so what I would like you to do right now is pause this video, rewind it, watch whatever you need to watch to finish up to make sure you know what's going on. Again, this only works if it is a perfect square trinomial, and this one and completing the square are the only times where it does not have to equal 0. The equation does not have to equal 0. It can equal anything. So, take a look down here. There we go. Here are some practice problems. Don't need to do all of them, because that's a lot of problems. I just need you to see that a few of them are done. So, what I would like you to do, let's do this third column here. So right now, I would like you to finish up or to work on this column worth of problems. Take a moment in class, well, a couple moments. It's going to take you a couple moments to finish those up. The directions say round to the nearest hundredth. I'm going to say leave it in, excuse me, leave it in radical form if you need that. So if it works out pretty like this one does, great. If you need it to stay as a radical, because otherwise it would be a decimal, like this one, please leave it like that. Don't round to the nearest hundredth. Just give it to me as a radical. So, work on those. That's your class assignment for today. There will be a second video where I show you the answers to all of those. And we will go over those by the end of class today. If you have any questions, make a note of them, and we can answer those hopefully tomorrow if I'm back at school tomorrow. That's all. And if you have questions, feel free to work with each other and ask each other questions as you work. Have a good day, and I'll see you later.